And finally, we have 2, 4. And we should know that this graph is a continuous graph. What I mean by that is we connect those points with curved lines. That if I put in a negative 0.5, I get a value out. If I put in negative 1.5, I get a value out, so on and so forth. So that is my graph of f of x equals x squared. Now let's talk about domain and range. We're going to talk about domain and range by just looking at the table and the equation, and then we'll talk about how to get domain and range just looking at the graph. All right, domain and range looking at these values. Remember, domain is your input. You're asking yourself, what values am I allowed to plug in for x? And in fact, it's probably easier to look at which values you can't plug in for x. Are there any numbers that you can think of, positive or negative, that you're not allowed to square? The big thing is look at, are you allowed to square negative numbers? Are you allowed to square 0? Are you allowed to square positive numbers? Yes, I can plug anything I want in there. So that means my domain would be negative infinity to infinity. Bless you. No matter how small, and what do I mean by small domain? No matter how negative a number is, so negative 1 billion. If I plug in negative 1 billion in here, will I output a negative number? Can I ever get an output being a negative number when I square something? No, it's always going to be positive. What's the one exception to that? It will always be a positive except for 0. So 0 must be the lowest value that can pop out of here. That's the smallest value that can be output from this equation. If I plug in a negative number, it becomes a bigger and bigger positive. If I plug in positive numbers, it just keeps going positive. So the smallest number our output can be is 0. So our range will be 0 to infinity, including 0. So we are going to put a bracket around there. So I can input whatever I want, but the smallest range can be is 0, can't be negative, but anything bigger than that will work. Let's pretend all I had was the graph to look at. I'm just looking at a graph of something. I don't have points on here. In fact, I don't even need these numbers on here. I just need to know this is 0, 0, and I can get the domain and range. Your domain are your inputs. That means your domain are your x values. Once again, your domain are your x values. So when I'm asking you about domain, I'm asking you left to right. What is the furthest left your graph goes to how far right does your graph go? So I know this is going up and up and up, but I'm talking about left and right. So I'm thinking about, okay, this arrow is going this direction, so if I go all the way over here and I go up high enough, I'm going to find that graph. Because this arrow is going up in this area, I'm going to keep going this direction forever, which means my domain starts at negative infinity based upon this graph. This arrow to me for domain is basically pointing this direction. So our domain from left to right, well, it would start all the way over there. And then same thing with this arrow. How far right does this arrow go? Well, this arrow will never stop. It will keep going right forever. So our domain stretches from left to right, all the way from negative infinity to infinity. That is domain. If domain is left and right in our x values, our range or our output must be our y values. So that must be our lowest to highest point. So if you're on a graph and you put your finger on this graph, you're going to ask yourself, how low does this graph go? I can't go any lower if I keep my finger on here. So my lowest range value, my y value, will be starting right here, including that, which is our y equals 0. And if we look at our arrows, it will continue to go up forever, so this will be my range. My range starts at 0. Remember, our range are our y values. It starts at 0 and goes forever. That's how you read a graph looking for domain and range. Domain is left to right, x values. Range is lowest to highest in that order for y values. In fact, everything we use will be x values except for range. Range will always be y values. You should know that. All right, our next one is a square root. Well, if I do the square root of -2, let's plug that in. Square root of a -2. Does that have any real numbers as an answer? No, so we're going to say that's undefined. So I'm trying to graph this on a real plane. Well, the square root of -1, that is also undefined. Square root of 0, that works. That turns into 0. Square root of 1, that's just 1. Square root of 2, that is 1.41. 1.4. Looks right.
Yes.
Yeah, that's good. All right, and then square root of 4 is the big deuce. And square root of 9 is 3. All right. Our domain is going to be different in this one. Domain is what possible numbers am I allowed to put in and get something out. Well, if I put in -1, I get out undefined, so that doesn't work. That breaks it. -2 breaks it. -3 breaks it. Are there any negative numbers that I can put in there and actually get an answer out? No, there's no negative numbers that work. The smallest number that's going to work is 0. 0 works. I can plug in 0. I can plug in 1. Can I plug in 0.5? Can you take the square root of 0.5? Yeah. You can take square root of any positive number and 0. So that means our domain just can't be negatives. So that means I'm going to go, my domain is 0 to infinity. 0 is the smallest number I can plug in, since I can't plug in any negatives. Are my range based upon this information? Well, I can't plug any negatives in. I can't get any negatives out. The smallest y value I'm going to have or output is 0. So this will also be 0 to infinity. So now I'm hoping my graph matches up with this. I'm hoping that my graph, the furthest it goes left is 0, and then it goes right forever. And I'm hoping the lowest it goes is 0 and can go up forever. So let's see if that matches what I think it does with this domain and range. So let's plot our points. Our first one is 0, 0. Our next one is 1, 1. Then we have 2, 1.41. We're going to have 4, 2. And finally, we have 9, 3. So we're going to Well, our domain is how far left does this graph go? So if I put my finger on here, this is as far left as I go. Remember, domain is how far left and right. Those are your x values. This x value is 0 here. So we'd go from 0 to infinity. Maybe I should do it the same way I did last time. So we have domain. Starts at 0, including 0, and goes forever. For range, I'd probably put it right there, but I'm zoomed too far in on mine, so I'm just going to put it over there. Really doesn't matter where we put it, or even that we put it, just that we understand that our range is how low does our graph go to how high does it go. So if I put my finger on here, this is the lowest I can go. Anything I put up is higher and higher and higher and higher and higher on our y value. This will keep going up forever, so our range goes up forever. Domain goes right forever. That is our graph of our square root of x, and that is our domain and our range. Our next one is cube roots. Cube roots, you are allowed to plug in negative numbers. A cube root is just a number that I can multiply 3 times by itself and get that value out. So when we're talking about cube root of -8. Let's go back to black. So we're going to do the cube root of -8. Well, I'm looking for a number that I multiply by itself 3 times to give me -8. Well, if we take -2, -2 times -2 is a +4. +4 times -2 gives me a -8. So when I take the cube root of -8, it is actually -2. It is defined. Any odd root, you can plug a negative number in. Any even root, you can't put a negative number in. So if this was a 4 up here, -8 wouldn't work. If it was a 5, -8 would work. So odd powers for exponents of of a root work. Evens do not for negative numbers. All right, our next one is cube root of a negative 1. That is, in fact, negative 1. Negative 1 times negative 1 times negative 1 equals negative 1. Cube root of 0, that's still 0. 0 times 0 times 0 equals 0. Cube root of 1 is 1. 1 times 1 times 1 is 1. And finally, cube root of 8 is going to be 2, because it's 2 times 2 times 2. So the graph of this will be negative 8, negative 2. Then we have negative 1, negative 1. We will have 0, 0, 1, 1, and finally 8, positive 2. Your graph's going to look something like that. All right, let's use a graph to come up with our domain and range. Well, domain is how far left to how far right this goes. How far left does this graph go? Yeah. What was that? Infinity. How far right does it go? It goes to infinity in that direction too. So we can go, our domain goes from negative infinity to infinity. Well, that means when I'm writing my domain, I'm just going to put negative infinity to infinity. But that matches kind of my assumption. I can plug any number I want in. I can plug negatives in. I can plug 0 in. I can plug positive in. So that works for when I plug stuff in. And what I can get out? Well, if we look at those arrows, even though it kind of looks like it flattens out, it doesn't. It just keeps going down forever. Just like this one, it will keep going up forever. So our range will go from negative infinity to infinity. Well, that kind of makes sense if I think about plugging stuff in. I can plug in a really big negative number and get a big negative number out. I can plug in a really big positive number and get a big positive number out. So it goes in both directions. That is our domain and our range. All right, the next one we're going to do is we have... Oh, I'm missing a graph, aren't I? I thought I knew that from the last class. I guess I didn't learn my lesson. No, make it bigger. All right, here we go. All right, we have x equals y squared. Well, that means my y isn't all by itself. My output isn't all by itself. So let's get it all by itself. The only way to do that is to take the square root of both sides. However, when you take the square root of both sides of something, you have to account for positive and negative. So x equals y squared is really y equals positive and negative square root of x. Let us look at some numbers. Let's look at negative 1, 0, 1, 4, and 9. All right, now we have positive or negative square root of x. When I plug negative 1 in, does that work? Now that I have positive or negative? No. It would just be positive or negative undefined. Adding a positive and negative up front doesn't change whether you can do something or not. So plugging in a negative 1 would still be undefined. Plugging in 0 will still come out with 0. The problem comes in our next one. Square root of 1 is 1. But they're saying take it the positive and negative versions of that. So that's positive and negative 1. Square root of 4 is 2, but they're telling me to do the positive and negative 2. And finally, 9 would be positive and negative 3. Just looking at the table, is that a function? No, that's not a function. These are our letters. Letter number 1, our input, goes to 2 outputs. That isn't allowed. That means this graph probably won't pass the vertical line test, and let's see if it does. So we'll plot the point 0, 0. We'll plot the point 1, 1, and 1, negative 1. Yeah, and then we'll plot 4, 2, and negative 2, and 9, 3, negative 3. That is definitely not a function. So that is not a function. If it's not a function, most of the time I won't ask for the domain and range because the domain kind of is broken and so is the range. But based upon that graph, what would our domain be if I made you find the domain of it? We're going how far left to how far right we go. What is the domain of this non-function? Yeah.
It's just 0 to infinity.
It'd be 0 to infinity. Perfect. And what would our range be, even though it's not a function? What would our range be if I asked for the range of this graph? How low to how high does this graph go? Liv. Negative infinity to positive infinity. It's going to keep going down forever, even though it kind of looks like it does off. If I throw in a giant billion, our answer will be a giant number and a negative giant number as well. All right, the next thing we're going to have is Pierre, our mountain climbing ant. Ugh. That is Adam's twin brother. If you remember Adam the ant spent a bunch of time on our second hand of our clock. Nope. From Mark period 1 in the beginning. Nope, never heard of this guy.
Wait, in this class?
It was in this class.
What a cool tie together.
We had Adam the ant was on the second hand, and depending on how close he was and how far, we determined how fast he was going along that clock. That was Adam. Well, this is his twin brother. So you can get to know his twin brother, Pierre.
What happened to Adam?
Well, Pierre's always trapped on graphs, and he's kind of lame because he only can walk in one direction. He only can walk in one direction. He's on your graph, and the only direction you can go is left to right. Which is just like what you do when you're reading a book. You read left to right. That's how you're supposed to read graphs too. We work left to right. Well, Pierre's walking on the graph, and he's always going left to right. If Pierre is ever going uphill, so he's going left to right, so right now he's going uphill right here. And he'd be going uphill right here. Your graph is known as increasing at those intervals. So whenever Pierre is walking uphill, walking left to right, he is increasing. When we do increasing, constant, and decreasing, you have to use your x values. That's why the only thing written on here are your x values. So once again, you will only use x values when you're doing increasing, decreasing, and constant. Don't be the one that uses y values, all right? Because there's, statistically speaking, 2 of you will. But we only use x values. Once again, the only time you use y values is for range. That is the only time you use y values is for range. Everything else, you're going to use x values. So we're using x values. And we're saying Pierre is walking uphill from here all the way to here. Well, here, if I'm using my x values, he started at negative infinity. He started way back there, really low. So he's starting at negative infinity. So we're increasing from negative infinity to negative 3, and we're going to use a parenthesis. He's also going uphill in one more place. So we're going to union that with, he's increasing from here to here. Well, you find your x value at the starting point, that's 1. And we find our endpoint, which is 4. So we're going to use parenthesis 1, comma, 4. But why do we use parentheses instead of brackets? I guess one of the easiest ways to look at that is, am I moving forward or backwards right now? Neither. You don't know which way I'm going until I take a step. So if we look at negative 3, right when Adam gets to the top of this hill, not Adam, that's his brother. This is Pierre. Once Pierre gets with her twin brothers, it's hard to keep them together. When Pierre gets to the top of the hill, he is no longer going up, nor is he going down. He is in the midst of going up and down at the same time. So that's why we always put parentheses, because nothing happens at one point. He is neither going up or down. So we always have to use parentheses to account for the fact that he's not going up or down at that point. The big thing is always use parentheses for increasing, decreasing, and constant. It never changes. We will always use parentheses. All right, the next thing is Pierre is sliding. If Pierre is ever sliding down the graph, it means that it is decreasing. Once again, Pierre must go from left to right, so the only time he'd be sliding is left to right. Now he'd be going uphill. So he starts going downhill at x equals negative 3, and he stops going downhill at x equals 1. So that interval will be negative 3 to 1. Finally, when Pierre is just walking straight, he's not going up or down, we have constant. So from here to infinity, Pierre will be walking a straight line. So he starts walking constant at 4, and he has to keep doing that for the rest of his short ant life. Okay, so we have 4 to infinity for that constant. That is increasing, decreasing, and constant. Your big things are, you have to read your graph left to right, you have to use x values, and you have to use parentheses. You have to keep all 3 of those things together on this. Otherwise, you mess up one of those, you mess up everything. Like if you read right to left, now you're completely mixed up, and now you think that this part is decreasing. So left to right, if Pierre's going uphill, it's increasing. We use x values in parentheses. If he's going downhill, it's decreasing, uphill, and finally constant. All right, the final thing we are going to do is we're going to look at this graph. First, we're going to fix it. Note we have a negative 3 and negative 2 in the wrong places. Oof. So we should probably get rid of those negative signs. So let's get rid of that negative sign there and that negative sign right there. I have a hard time doing that just because there we go. There we go. All right, just take a second and try to fill out all of that. You're going to fill out your domain, range, increasing, decreasing, and constant, and then we'll come together and get all those values together. So you are in charge right now of coming up with your domain, your range, your increasing, decreasing, and constant. I'll give you about 4 minutes. Remember, let Pierre help you. Good aunt. I like Adam. Adam struggles him. Let's go through these together. Who thinks they have the domain? How far left to how far right does this go, Rena?
Negative infinity to infinity.
It would, in fact, be negative infinity to infinity. What would my range be? How low to how high does it go, Chris? It goes negative 3 to infinity. Would it include negative 3? Yeah, it would, because there's a closed dot right here. You know it wouldn't include it because I'd have an open dot. All right, so yes, it would include negative 3, so I'd have a bracket, negative 3 to infinity. Where is it increasing? Brody.
-5 to -3.
Union with, yep.
1 to 1. Right, negative 1 to 1.
And then union that with
4 to 5.
4 to 5. Does anyone disagree?
Do you do brackets?
You never do brackets.
Okay, I did it.
Okay. We'll never use brackets for increasing, decreasing, or constant.
Okay.
Because at that point, we don't know if they're going up or down. All right, decreasing. Who's got where it's decreasing? Ooh, no takers on that one. You're the same two people as the other one. Brian. At 1 to 3. Let's see, so at 1, 2, I don't think it's 3, I think it's 4. Yeah, it's hard to read that graph. Things don't line up exactly how they should. Do you agree it's 1 to 4, though? All right.
I disagree
You disagree?
with that answer.
Okay.
I have negative infinity.
Hang on. Let someone else answer. Liv?
Negative infinity or negative 1.
Yeah. Does that mean 1 to 4 is wrong?
No.
No, it just means we need to also include negative infinity because it's going downhill, negative infinity, all the way to 2, 3, 4, 5. 5, right? And union that. All right, where's the constant? Oh, yeah.
Okay, because I have to complete Brian. Okay, so -3, -1.
-3, -1.
Yeah.
Okay.
And then 5 to infinity.
And then 5 to infinity, yes.
So Brian, see, you didn't even get it right, Come on.
Why are we dragging Brian? Why are we all diming each other out in this class today?
I don't know.
Sorry, Dad.
All right, this is about as complicated as they get because it's got everything on there. It's got kind of a shoddy graph with numbers that you can't really read. If you guys can do this, you should be able to do anything I can throw at you as long as you can graph it properly. All right, guys, the rest of the time is for you to work and ask questions. I'm going to hand back your tests. Then I'm going to check your homeworks. And by then we